Hello, today we're going to be talking about linear inequalities. So an inequality is going to be something where you're going to have an entire portion of your number line that satisfies your inequality. You're going to get lots of different answers versus an equation where you might get one or possibly two different answers. So for linear inequalities, you're going to have to write your answers a couple of different ways. One of those is set notation and one of those is interval notation. Now in set notation, what it's going to look like for your answer is you're going to have this squiggle or this set bracket. All of the set notations are going to start with that set bracket. Then what you're going to do is you're going to write down your variable that you used in the problem. So you're kind of setting up this and you're saying, hey, I'm using this variable. And then you're going to draw a vertical line. Now that vertical line means such that. So this is saying I solved for x and this is what happened. And then after that, you're going to take and write your answer. Normally, you're not going to have that bracket underneath. You're just going to have like x is less than a number. So what's happening is this portion here is your actual inequality slash the answer. After you've written out the inequality or the answer, you're then going to close it with your set bracket. So an example of this would be x such that x is greater than or equal to -2. That would be your set notation. So set notation is one way of writing your answer. Interval notation is going to be another. It's just like speaking a different language. You're going to be saying the same thing, but you're going to be saying it a different way. So in interval notation, it's more of a visual interpretation. You're looking at left to right. What are your answers, or what is being shaded in your graph? So you're looking at specifically what are your answers. And so what you're going to do is you're going to look at the number line. And if you're thinking of values, normally on the left of your number line, the numbers are getting more and more negative. So if it's pointing to the left, it's actually pointing towards negative infinity. Versus on the right-hand side, you're going to look at those numbers and they're increasing. They're going up to positive infinity. So if your graph is shaded on the left, you're going to start off with a negative infinity. If your graph is shaded on the right, you would end with positive infinity. And now these infinities here are always going to have parentheses when you are using interval notation. So it'll either start with a parenthesis or end with a parentheses depending on where your infinity is. On your number line, you're also going to be seeing solid lines or solid circles, or open circles. If it's an open circle, you're going to have a parenthesis either on the beginning or on the end. If it's a filled in circle, you're going to have a bracket either on the beginning or on the end. So let's go ahead and take a look at some of these examples in interval notation and then set notation. So we're going to start off with interval notation for A. So left to right, what is shaded? So looking at this graph here, nothing on the left is shading. My answer starts here at 4 and is being shaded to the right for forever. So I go left to right, it's starting at 4 and pointing to the right for forever, which is positive infinity. So my interval, once again, go left to right. I am starting at 4, comma, positive infinity. Now at each of these, you're going to have a parentheses or the bracket. So for the 4, you're looking at above, this is an open circle, so it's going to be the parentheses. The numbers are always dependent on open or closed circle for if the number has brackets or parentheses. Now it went to the right for forever, so it is a infinity. That is always going to have a parentheses with that. Versus the next one, let's actually move to B and do interval notation for all of these first. So for B, notice here, our graph is not shaded to the left at all. Our graph starts being shaded here at -30. And then after -30, it is being shaded to the right for forever, and to the right is positive infinity. So our interval starts at negative 30 and ends at infinity, whenever that happens. And so looking at this, at negative 30, we see this filled in circle, which means negative 30 is included in our answer. So we are going to have this bracket specifically for negative 30. And at infinity, this is a separate story. Infinity is going to have parentheses because we can never truly include infinity because it's infinite. So now C is pointing the other direction. So we notice here our graph left to right starts at negative infinity because it's starting being shaded to the left for forever. But then our graph stops here at 3/4. So instead of starting at a number for this one, because we're pointing to the left, we're actually going to start with negative infinity. And this one doesn't go on to positive infinity forever. It actually stops at 3/4. Now this one, since it starts at negative infinity, it's going to have a parentheses there. And at 3/4, that is an open circle. So open circles have a parentheses for interval notation. Now let's take a look at set notation for these ones. So for my first one, my set notation is going to start with the set bracket. I'm going to define my variable. Since it doesn't have one, I'm going to use x. So it's set bracket x such that, that's the vertical line. Now I want the half of the graph that's on the right. So what's happening is we're comparing x to 4, and everything being shaded to the right means we wanted all of the numbers that were bigger than 4. So our inequality is going to be x is bigger than 4. And then once we've written our answer out, we close our set bracket. For the next one, it's going to be similar. You're going to do your set bracket. We're going to define x such that, and then we want everything bigger than negative 30. So looking at this, we're going to be comparing x to negative 30. We shaded everything to the right, which was everything more than, but since it's filled in, it's going to be greater than or equal to. So open circles are just greater than or less than. Filled in circles are greater than or equal to or less than or equal to. So for this one, it was everything greater than or equal to negative 30. For your set notation for this last one, it's going to be x such that. Now what we're doing is we're comparing all of our numbers to 3/4, but we wanted all of the smaller numbers because we shaded to the left. So for this one, it's going to be x is less than 3/4. So that's in all of those different notations. We can apply that now in different cases. Given an inequality, what we want to be able to do is we want to graph that. So for this first one, we're going to go to 5 on our number line. And this is saying we want everything bigger than 5, which is going to be the numbers to the right. So what I'm going to do is I'm going to do an open circle because it's just greater than and it's not equal to. And then I want everything bigger than 5. So numbers like 6, 7, and 8 are going to work. For my set notation, I'm going to open up my set bracket and I'm going to use x such that, and this one I already had my solution given to me, x is greater than 5. So interval notation, as a reminder, is from left to right. So looking at this graph, left to right, my interval starts at 5 and goes to the right for forever. So I'm going to start at 5. Since I'm going to the right forever, that's going to be infinity. Now, infinity always has parentheses, but the number is going to be dependent on the circle. Since it's an open circle, it's going to be a parentheses. For my next one, I notice my graph is shaded to the left. So looking at this, I'm trying to compare x to 5/9, and since I wanted everything smaller than 5/9, x has to be less than 5/9. But the filled in circle indicates that it's less than or equal to 5/9. So for my set notation, I'm going to open up my set bracket and do x such that x is less than or equal to 5/9. notation, this is starting at negative on the left and at 5/9. So it's going to be a negative infinity to 5/9. The negative infinity always has the parentheses. The 5/9 for this one is filled in, so it is a bracket. For my next one here, I'm given it in set notation. So here it's saying my answer is everything smaller than 5/9. On your number line here at 5/9, this is everything smaller than it. So it's everything to the left, but your circle for this one is open circle. It's meant to be the same problem as the one before it, but the difference is it's not equal to for this one. Which means for interval notation, I'm still starting at negative infinity because it's still pointing to the left, parentheses. But then my graph is stopping at 5/9, but because it's not equal to and it's an open circle, it's a parentheses there. For this last one in interval notation, I tend to do my graph first because visually that helps me. I'm noticing my boundary here is 6, and I'm starting at the left for forever at negative infinity, which means my graph is pointing to the left. At 6, I see the parentheses, which tells me it's going to be an open circle. And so now looking at this, I notice that I wanted everything smaller than 6 for my answer. So then my set notation would be x such that x is less than 6. So these were kind of giving you all these different examples and being able to write the inequality, the graph, set notation, and interval notation. We're going to start off then solving a couple examples here. So we have x minus 5 is less than or equal to 10. We want to be able to solve that and then graph it and answer for our interval and set notation. So to solve it, we're going to get x by itself by adding 5 to the other side. We get x is less than or equal to 15, which means on my number line, 15 is going to be my boundary. I'm going to have a filled in circle, and I want everything smaller than that, so it's shaded to the left. Which means based off of that inequality, I can look at this and say it's shaded to the left, which means negative infinity, and my graph stops being shaded at 15, and it's filled in, meaning it's a bracket. For my set notation, I open my set bracket, and it's x such that, and then I write down what my answer was, which is x is less than or equal to 15. For this next one, now I'm changing my variable. I want to get d by itself. I need to add 12 to both sides. So this is saying 20 is smaller than or equal to d. Now normally, we don't like looking at it like that. Normally we want the variable to be on the left side. So let's kind of look at what's happening here. 20 is supposed to be smaller than d, which means d needs to be bigger than 20. I'm going to rewrite my inequality so my variable's on the left, but when I do that, be very careful that you switch your sign here, because you're actually wanting all of the numbers that are bigger than 20 or equal to 20. So then my answer in interval notation is going to start at 20, and at 20 you have a bracket, and it's shaded to the right for forever now, which is positive infinity. So with set notation, be careful here because we're not using an x anymore. Our variable for this problem was d, such that I got an answer bigger than or equal to 20. And for our last one, we're going to get z by itself. We're going to go ahead and multiply by 2. So z has to be bigger than 12, which means on my number line, I go to 12, and I do an open circle because it's just greater than and it's not equal to. And since I want the numbers bigger than 12, I shade to the right. So interval notation, my graph starts at 12 and is pointed to the right. Infinity has a parentheses and so does 12 because it's an open circle. My set notation is the squiggle, and then my variable here was z such that z is bigger than 12. So just a quick reminder, interval has the infinities, set has the squiggles, and you can graph and go in between those different notations. Thank you very much for listening.